Hello, this is checkpoint 2.2 from section 2.1. It says that an object moves along the coordinate axis so that its position at time t is given by s of t is equal to t cubed. They want us to estimate its instantaneous velocity at time t is equal to 2 by computing the average velocity over the time interval from 2 to 2.001. All right, this is our graph. This is our graph y is equal to x cubed, and we are looking at the point 2 comma 8. That's when we put 2 in there, and and then we want to go a little bit to the right of that to 2.001 and find the slope of the secant line. I think it might be better if we blew this up a little bit, and we'll take a look at it here, blown up. This is our magnification. And the graph, this little bit of graph is going up here. It looks almost like a straight line because we've zoomed in fairly close to it. And we have this point that we have identified as 2 comma 8. All right. Now what they want to do is they want to move just a little bit over at 2.001. So 2.001, and what we want to do is figure out what the y value is when you put 2.001. So it's a matter of taking it to the third power, and let's see, if I take my calculator and put 2.001 and take it to the third power, I get 8.012006001. All right, so that's my second point. And what we want to do is estimate the instantaneous velocity. So we'll call it instantaneous velocity. And this is going to be estimated, and what we want to do is use the average velocity. So the average velocity between 2 and 2.001. And so to get that, what this will entail is for us, we need to find the velocity function. They're calling it s of t there, or that's the position function, s of t. We want s of t evaluated at, it doesn't matter which one goes first as long as we're consistent. So I'm going to put 2.001 first minus s evaluated at 2 divided by 2.001 minus 2. Okay, so this is what we want to compute. And just to note, this is s of 2. And this big number here is s of 2.001. Okay. All right. So this says 2.001. Now, let's just plug those in. We put in the value. So we have, for the first one, we have 8.012006001 minus just 8, and then we're going to divide that by 2.001 minus 2. Okay, now the whole numbers go away, and it looks like we just have 0.012006001, and the 8's cancel, and then here we have 001. All right, and I think to simplify this, we just move the decimal place 1, 2, 3 times to the right, 1, 2, 3, and then we're going to get this to be equal to 12.0006001. Again, there's a 1 there, at the end, and that would be our answer. So this is just an approximation. To get the exact value, we would want to push this closer to this point, which means we want to probably put in 2.000001 or something really close to 2. And then we'll probably end up seeing this to just be equal to 12. But we're not quite there, but we are able to find approximations. And then we'll get the actual value when we take the limit. All right, I hope that helps.